All right, everybody, welcome back to Uncertainty, the Logic of Science, Probability, the Logic of Science class. This is episode 18. Probability does not equal propensity. Probability is not physical. Probability is not real. Probability is not a physical thing. That's our lesson for today. But before we get to that, I want to get to something that came up in the homework or in the comments of this section. I have some people, there's a good reason I insist that I write probability as I do. Now, notation can mean quite a lot. Notation can help you, notation can harm you. And I've been insisting that we write probability a certain way just to remind ourselves exactly what we're doing. And so let me ask you this question right here. I'm going to tell you what this is. Let's see here. Okay. This is notation for something. Not going to tell you what. It's notation for something. I want you to tell me what the probability of this something is. Well, yes, I hear some of you saying, I don't know anything about this thing, so how can I tell you what the probability of it is? Okay, so this is the wrong way to write probability. This is a way to write probability. It's not necessarily wrong, but it's a very unhelpful way to write probability because we have forgotten something. We have forgotten the condition on the information. Well, we can condition on the information. I don't know. Don't know anything. All right, that's a useful thing. And you don't know what that is. You have no idea what this is. You don't know anything. How can you say anything about something you know nothing about? I don't know anything is the same thing as saying I know nothing. And this is a very strict, very rigorous word. Nothing. It means nothing. It means no thing. It means the absence of anything. I don't know how to stress that more clearly. If you have a way of stressing that more clearly, please let me know in the notes, and I'll use that from now on. If you don't know anything about this particular thing here, this proposition, it's a proposition, well, then the best we could say is the probability is in, this is the mathematical symbol in, somewhere between 0 and 1. And the reason we did that is because we have deduced probability can be a number. We've deduced its functional form. We've deduced 0 and 1 are its end states. This is these square braces on the end mean that it can be any number between 0 and 1, including 0 and 1. So it can be anything. That's what knowing nothing means. Knowing nothing means it can be anything. You could try to do this, and this was part of our reading, well, that this thing could be, we could say this object, the proposition can be true or false. And you could say that's the knowledge I have, and you could try to say then that the probability equals 1/2. But that doesn't work. That doesn't work because any proposition can be true or false. Any proposition whatsoever, Bigfoot landing on the moon and his UFO can be true or false. Any proposition can be true or false. This is a tautology. Remember, this is it's a logical tautology. Tautology, and it adds no information. Tautology, I got a little bit of dyslexia going on there, but you get the idea. It is a logical tautology. It's like multiplying an equation, an algebraic equation by 1, or the identity. It doesn't give us any information. Saying this thing can be true or false says nothing. Almost always, when you're writing something, this is just a proposition. When you're writing a proposition about a real thing you know something about, say, for a coin flip, and you want to say something about heads. I know something about coins. My background knowledge, I'll just call it coins background knowledge. Now I know something about coins. And you might come to some probability for that. That's not no information. That's not knowing anything. Of course, if we know the full causes, and the conditions behind a flip, why that probability will be either 0 or 1 depending on what the causes and conditions tell us. So The whole point of this kind of a thing, if we don't write probability of some proposition A with respect to some knowledge B, if we forget this B part here, we are apt to confuse ourselves. We are apt to confuse ourselves. And if you have to write A and B as shorthand, that's perfectly fine. But a lot of times it helps to write out the entire thing. I mean, mathematicians don't like to do that because they like to work with symbols, and it makes the work a lot faster and it facilitates thought, mathematical thought at any rate. But when we want to apply math to real things, now we're trying to apply math to our thoughts and about how the world works and our knowledge of the world, then it helps to write out entire sentences. Then it helps to think about what's going on. I don't know anything about this bizarre symbol. I know nothing. How can we jump from nothing to giving it a probability? We can't. You can't. There's no way to move from nothing to something. We have to have some information. In coins and very simple systems, I say, I know it has to be this state or that state. That's not a tautology. It's not a true or false. It's nothing like that. It is a state. It has a physical state. This state, it has a physical, which is a head, for instance, and it has a physical state, which is a tail, and so on and so forth. So we're not going to make that mistake. And not making that mistake, we're going to use this kind of a notation to help us understand why probability can't be propensity. So let me erase all of this. And I'm going to prove to you, I don't know how many people think probability is a propensity anymore. There's a few, some, especially in quantum stuff, which we'll talk about in a second here. But I don't think it's that much of a mistake that is made anymore. It used to be very common that people thought that probability was a real thing, a real propensity of things. And you'll hear things like this. People will write the probability of a boy being born, for instance, a human boy, if we're still allowed to talk about that, they'll say it's something like, oh, it's 0.51. Now, you could do this, you could write down this kind of thing just as I said before, but this is wrong. This is absolutely wrong. It's not wrong. It is to say it is forgetting the information that we have, and it's coming like, it leads us to believe that the probability of a boy is built into the male and female bodies somehow, and the male and female bodies are angling towards pushing this probability so it realizes itself in the population. No, what we really should write is the probability of boy given our measurements. What do you want to say? Our observation, we'll call it obs. That's a good one. Our observations is about 51% of the time a boy is born. Well, that depends, right? That depends. If you're in India, the probability of a boy goes way up. If you're in China back in the days when they had a one-child policy, the probability of a boy goes way up. Why? Because the causes change. The causes and conditions. We're always trying to think about causes and conditions of things that bring about effects. That's what science is all about. And it's not the knowledge of these things that brings the effects about. It's the actual substances, the things that have powers, that have causal powers and so forth that bring things about. So let me prove to you, if this doesn't already, prove to you that things themselves do not have probability as a measure. Now, for instance, I'm a little over 6'2". That's a height. That's something I possess. That's a property I have. All right? And you may be somewhat benighted. Let's say you're 5'10" or something like this. Now we have a relation between us. I am 4 inches taller than you are. That relation is 4 inches. That relation doesn't exist. What exists is my height and your height. The relation is only a matter of our knowledge of these things. The relation itself doesn't exist, but the bodies themselves do. And so probability is a relation. A probability is just logic, and logic is nothing but relations between sets of propositions, and that's all probability is. Physical reality is, here's a body standing, it has a certain length, and here's another body standing, it has a certain length, and so on. The ontology is not the same as the epistemology. Okay, so here we have a game. We have a game, and the game says, this is our background information, our premises, our assumptions, whatever we want to say. The probability has a game, and the scores are possible. We can get a 2, 3, all the way up to 12. All right, that's our proposition. Now I want to know what's the probability of a score equaling 2 given this G. Just this G. I cannot stress this enough. This is it. That's the only information we have. Probability is a set of relations, is the relation between the sets of propositions that we assume. And it's nothing else. It's not G plus other things I'm going to sneak in there and not write down. It's exactly G and nothing else. Now, well, we've done this kind of thing using the statistical syllogism. The probability is 111. There's 11 of these states, is it? If I've counted correctly. And the score being 2. 2 is just one of these possible states. The score of 2 is G, 111. No problem, right? Now, but if I tell you the game is instead, it's G plus our knowledge of craps. And craps says I have 2 dice. I have 2 dice. And I'm going to get a score between, I'm going to add up the total. I'm going to throw these, and I must get a total between 2 and 12. I can get 1 plus 1. This equals, I can get 1 plus 1, I can get 1 plus 2, I can get 2 plus 1. I mean, 1 on the first dice, 1 on the first die, 2 on the second. I can get a 2 on the first and a 1 on the second. I can get a 1 plus 3, 3 plus 1, and so on all the way up to 12. And the same thing I could have the scores here is 2, 3, 3, 4, 4, and 12. No different. It's the same game, but I've added knowledge. I've added knowledge. The probability to this, the probability of the score equaling 2 given G plus the knowledge we're playing craps is now 1 over 36. It's the same game. It's the same game, same set of scores, but different probability for the same score because of adding in knowledge. That probability, if probability was a real physical thing, that probability would have to be, sometimes it would have to be 1/11th, and sometimes it would have to be, there it goes on the ground, oh, a 3. Is that lucky? And sometimes the probability would have 1/36. Some people take the probability to be a propensity, a physical part of these die somehow. And that they have to be, and that these in the world have to come together in some way to produce these results. So the probability itself becomes a kind of cause. The probability is in no case any kind of cause. The probability is only a measure of our information that we assume and nothing else. We change the assumptions, we change the probability. Therefore, because we could do that with the same physical setup, I can't have that the case is that the probability is part of these dice in any way, nor is probability a part of the human body. It just happens to be that causes are such that boy births are coming out the way they are and girl births are coming out the way they are. And those causes and conditions change. They vary from time to time, from culture to culture, and all these kind of things. So probability does not exist in that sense. All right, so I owe you this little explanation right here. And that's only because some people do insist, and again, I don't think it's as many anymore, but I do think some people still insist that probability is a thing. So we could have, for some proposition P, and I'm using this proposition P because that's the way I have it in my book, and I'll be giving at the lecture notes, I'll have that excerpt of my book, chapter 5, I believe it is. Yes, an excerpt of chapter 5. And I want to keep with the notation of that. And I realize it's kind of a pain on the board. So we have some process, some set of assumptions that we believe is physically existing in the world. And we have some proposition P that's related to this process. And if probability is a real thing, if probability is a physical thing, it's a propensity, we define the probability as being that propensity, P, whatever that P might be. I used 3 slashes as opposed to just 2 to insist to you that this is a definition. This is a definitional thing of what the probability could be. Now, logical probability is exactly the same. If we have some A and that's our background knowledge and we want to say something about P, well, it may be the case that probability of P given this A works out to be P, some number in 0, 1. But no, that's not what the propensity people say. They say this is defined to be. This cause is defined to be in a causal kind of a way, that probability is like electrical fluid. It's in the system somehow and making things turn out to be the way they are. That can only mean cause. They don't always say cause, but it comes out to imply cause no matter which way you slice it. And so this leads to something called the principle. I'm going to erase that and do that all again. There we go. This is a guy named Lewis, David Lewis, and he came up with something called the principle. He says that the probability that P of P given, it should be defined as this creature. Well, that's his definition of probability based on the principle. The probability of P, given the physical probability of P, given A is P, the probability of P given this is P must equal P, not defined to be equal P. Well, this is just too nice. It's just too much. It's too much for us. It's ridiculous. It's trying to work in physics, probability as a physical property of some kind or another. That's always absolutely undefined. Nobody ever quite defines what probability is of this kind of thing, and with the one exception being quantum mechanics. Now, I don't want to talk a lot about quantum mechanics today, except to insist to you that probability is not objects, small objects, do not themselves possess probability. What exists, and we have to talk about what it means to exist. This is the whole problem with quantum mechanics. There's all this confusion about wave-particle duality and the measurement problem and all these kinds of things. So there's a wave function. The wave function, they say, really exists, and I think that it depends on what we mean by exists. We can say that that's the case, and it collapses when it becomes a measurement. And then von Neumann's system of probability gives a probability for the measurement, not the object itself, for the measurement, which is very revealing. And it says we're dealing with our knowledge. The measurement is, of course, in a physical system itself, trying to say something about an underlying reality. And that underlying reality is the part that I think we go about interpreting in the wrong way. Now, there's all kind of ways. If you've read the blog, we'll talk about this. I think it has, if we talk about being as partly potentia and actuality, things that are potentially in existence and things that are actually in existence, and we could vary existence along that spectrum, then we have something with quantum mechanics. Robert Koons and others are working on this, to restore a kind of Aristotelian way of looking at quantum mechanics. And I think that's exactly the right way of bringing about things. This is what Heisenberg's original suggestion was, after all, to try to bring in these Aristotelian ideas. But for some reason or another, it was rejected because Aristotle himself was, Aristotle's notions of cause were rejected. They were, since Francis Bacon, scientists, and particularly philosophers of science, they wanted to remove teleology. They wanted to remove final cause from the world. They didn't want anything to have a directedness. Of course, everything has a directedness, including this video. That's why I'm doing this video. It has a definite directedness to it. So that that was ultimately, it led to some successes, and the reductionist way of looking at science, all that kind of stuff led to some successes. But now science is kind of stalling out, particularly in physics and so forth with quantum mechanics. We'll talk more about quantum mechanics when we talk about cause. I have a whole chapter, I think it's chapter 6. After we talk about all the things that probability is not, we will return to this quantum mechanical question. We will talk about cause and the different views of cause and so forth. But it's quite clear, I think, at this point that probability is not itself a cause. Probability is not a property of things. Probability is a relation between states of knowledge or states or propositions that we assume and so forth. And I'll just give you one more example to drive that point home. A very simple example to show you that sometimes even thinking about cause can fail us. So let's think about this. Let's say that all, oh no, I don't want to say all. Let's just say 1/3. 1/3 of all men wear hats. I used a different number in the book, I think. I can't remember what it is. 1/3 of all men wear hats. I'm going to assume this is true. Is it true in real life? Does it matter? Answer that question. That's a good homework question for you. Does it matter? The answer is no, it doesn't. But now you have to understand why. So that's one of our premises. And now I'll say George. Why did I use George? I can't remember. Is a man. And I want the proposition that George wears a hat. Now the probability that George wears a hat, given these premises, which I'll just call, well, we'll stick with James, call it B. Well, that's 1/3. Fine, right? Is there a cause in this? Is this probability that because 1/3 of the men wear hats, is it causing George to wear a hat or not wear a hat? We don't know. We haven't measured George. Is this probability urging him on through human nature? Well, you might say it is. Yeah, okay, maybe there is something in there. There's some innate gene 4 things. Well, we'll talk about gene 4 things another time. But let's change this to B prime. And we'll just change it. We'll keep exactly the same information as B, except we're going to substitute, we're going to take out men, and we're going to put in Martians. And then George is a Martian. George is a Martian. And we still have George hat as our proposition of interest. And now we have this also equals the probability that George wears a hat given our B prime. Now there are no Martians, and none of them could wear hats because there are none. But we could still form a recognizable probability for this. And there is no cause in any of this. I hope you can see, because there's no Martians, they can't put on hats, so we can't say anything about Martian nature or anything like this, because they don't exist. So we can't try to get at cause and work ourselves in backwards and say, aha, it must be, probability is really sneaking in there some way or another. The way things are working out, it just adds up to be this particular probability. No, it doesn't. Causes are entirely different. When we know the full cause and conditions, the probability has to be extreme, 0 or 1, and there's no uncertainty. When we don't know the full causes and conditions, the probability will be in 0, 1, with rounded parentheses, meaning not 0 or not 1. Maximal uncertainty, we could say and define maximal uncertainty as when the probability of some proposition A given B is 1/2. We can't be any more uncertain than that. Well, maybe. We can be more uncertain than that if we say, what's the probability of this? I forgot how I drew this thing, like this. Given what, you know, my words, or however you want to say it, any tautology, well, that's maximally uncertain because that's in 0, 1. That's really fuzzy. All right? That's maximal uncertainty. When you don't know anything, if you know nothing, you, that's maximally uncertain. Knowing nothing, you can't get more uncertain than knowing nothing. If you have certain information that does this, while you might, and it is the case that the probability of A given B is 1/2, in that numerical measure of fixed numbers between 0 and 1, where it has to be just one number and not an interval, why then you could say that's 1/2, and that's useful. That will turn out to be a useful concept when we talk about entropy, particularly maximum entropy techniques. To help us understand parameters and models and so forth. Well, we'll come to all that. But I can't stress enough, again, the whole point of this class is the probability of A given B does not equal the probability of A given D when B does not equal D. You change the probability, you change the information. As long as that information is probative of A in any way, you change the probability. Probability, again, is only a relation. That's it. Nothing more. It's a relation. It doesn't imbue itself in things. It doesn't have properties. It has no causal effect. It has no powers. It is only a measure of uncertainty given the things that we assume and nothing more. Probability can be a number. It doesn't have to be a fixed number. It can be an interval. That's it. Nothing more than that. Really simple, actually. And once we understand that, we're going to understand models a whole lot better and the limitations and uses of models and so forth. Well, the homework will be to read the excerpt that I'm going to put up online. You'll see all that. And maybe I'll put another question there for you to answer in the notes below. Until next time, we're going to keep going on this idea. I've forgotten what I was going to say. Subjective probability. We're going to do why probability is not subjective and what they mean by subjective in the subjective sense. There's different meanings of the word subjective. That's it for now. Thanks very much for listening. Links are below there, and you know where to find everything else.